Hey everybody! Thanks again for taking another chunk of your day to either watch me live or take a look at the video of this office hour session for DynamoDB. My name is Rick Houlihan. I'm a senior practice manager for DynamoDB service team, and as many of you know by now, I'd like to do these sessions kind of regularly where we do data modeling or we talk a little bit about features and functionality around DynamoDB. And we were supposed to be doing a global tables deep dive and demo. I was going to have a special guest today from the engineering team. Unfortunately, my co-host for the day was not able to make it, so we had to scramble at the last minute. For those of you who are expecting that global tables demo, we're going to reschedule that a couple weeks out from now. And today, what we're going to do, I sent out last night another tweet where we're going to talk about actually modeling a mobile payment service. So I figured I'd do another live data modeling session. Since folks seem to like that. So hopefully that'll be interesting for folks today. And just kind of start off the show real quick. If there's anything that anybody wants me to address, folks have looked at the model that we're going to let me go ahead and pull that up real quick here. So this is kind of the data model we're going to look at here. We've got, kind of revolves around customers. Customers have phones, phones have network providers, so on and so forth. Phones are also tied to various accounts. And what's interesting about this model, I was kind of a little confused on what the accounts were. So I'm going to interpret the accounts as, payment, basically mechanisms, credit cards, PayPal, whatever, the things that we're paying, the payment instruments, right, that we're going to be, executing within our transactions, which means I'll probably have some other relationships that aren't really defined in this chart between the actual accounts and the transactions, so to speak. So we know which accounts were used to pay for what transactions and so on and so forth. Retail outlet types and retail outlets is pretty straightforward, right? These are all the providers of which I'm using my mobile, payment device for, and how we what transactions are executed, right? We're during this. So I'm actually going to say, hey, this mobile payment method, that's actually going to become the accounts table in my model, because I couldn't really justify it. To me, a cell phone or a mobile phone has one account that it's tied to. I'm not aware of mobile devices that can have multiple accounts they're associated with. If you have multiple SIMs, then fine, but that device is, for all intents and purposes, the SIM that's plugged into it, right? Not, it's not necessarily aware that it's used in multiple SIMs. So anyways, small detail. If anyone has any patterns that they, looking at this model that they'd like to look at, here's one of the first questions we got up there. I'd like to know about secondary indexes in DynamoDB in today's session. Absolutely. That's a lot of what we're going to do when we do the modeling. We kind of go through, here's the table, here's the set of access patterns that we're going to set up on the table. And then as we start to look at the data, we're going to say, hey, there's little bits and pieces of this data that we want to access in multiple ways. And, then I'm going to have to add indexes to support those additional access patterns, right? So it'll be some, again, primary set of access patterns, I imagine will be like, give me all the cell phones for a customer, give me all the transactions for a cell phone, things like this. We'll model those first. And those will be kind of like table access patterns. And then when we get into, okay, well, give me all the transactions that were, associated to a given account or payment instrument, right? Then, that's going to be, okay, well, now maybe I'm going to have to start looking at indexes and why I might use those. So we'll definitely talk about, some of that stuff. I'm just checking out some of these tables here. So, user here is asking for some help. Maybe one of the moderators can give you a little advice there. It's how to connect to the table. This is probably permission security groups. That's actually a really good idea. I think for one of my sessions, that's what kind of walk through, right? How to deploy a table, how to connect to a table from an instance, how to set up the security groups and all that kind of stuff. We don't talk a lot about that stuff. And for new users, that can be actually really helpful. So I think that's what I'll do. I'll put that on the agenda for a future session, right? Just the basics, right? How to get it connected, how to, hook up and initialize the clients and the various platforms and SDKs and whatnot. That sounds like actually a good subject for a future talk. And again, a couple of moderators on today. We got Lee, we got Rob on the channel for doing moderation during the discussion here. And with that, we'll just go ahead and launch right into things. Again, we talked a little bit through the the schema already, right? So kind of the top level entities here we're dealing with are customers and cell phones or mobile phones, mobile devices, and again, they have attributes, network providers, whatnot, are kind of a secondary of interest to us. Although we might have an access pattern that says, hey, get me all the, mobile devices for a given network provider. Okay, so then that might be one that we'll go ahead and model. But let's just go ahead and get started with creating that table. For those of you who are familiar with our modeling tools, we've got multiple options with DynamoDB now. There's the NoSQL workbench for DynamoDB, which is our console-based application. And then there's this tool, which is an evolution of the tool that was built by the Black Belt team. And both use compatible models. You can create a model in one, export it, save it, and import it to the other. This tool I prefer these days because it has a little bit of extended functionality that I've implemented around entity types, which really kind of lead towards that single table model. So let's go ahead and create the model that we're going to be looking at today. This is the mobile payments service. And again, I like generic keys. For those of you who know, all my tables are basically one. They have PK and SK. PK is our partition key. SK is our sort key. And I usually call my table data because I stick a lot of different types of data in it. So I don't really want to give it a specific name unless it's the name of the service or whatnot. I do that as well. But for our demos, I always call my tables data. And so let's take a look at our entities here. We've got, first we got a customer. Customers have one-to-many relationship with their mobile devices. So let's go ahead and just create that relationship here. Our first entity will be a customer entity. And that's going to be some customer metadata record. We're going to say, and I don't even know if they call out many attributes there, basically name and other details. That's fine. We can go ahead and add those attributes. So name and details. John Doe. John Doe does a lot of stuff. And just basically, that could be a map attribute of all the extended details. Probably have some additional indexing attributes later. But for now, that's kind of our first entity as a customer entity. Let's go ahead and add another entity to the table, which is going to be a mobile device. Okay, so and you can actually, one of our access patterns right away, we can tell is, okay, give me all the mobile devices for a given customer. So I'm going to want to add some sort of a prefix on these things. I could just put mobile device number, right? Whatever it is, But if I do this, what's interesting is I got one of my patterns that I'm going to do later is so this will be a, device. I'm probably going to want to get all the transactions for a device, right? So if you think about that, if I say, okay, I probably want to have some date range, list of items that are prefixed on the phone number, and then I have another access pattern that says, hey, get me all the mobile devices for a customer, then I kind of prevented that pattern from occurring if I just use the mobile device number as the sort key. So I probably want to add, something else here as a short key, which would potentially be like a prefix. Could say, hey, this is a device. So we'll have a device prefix. And so now when I go in ahead, and if you notice, it resorts the items every time I change the sort key, which is why it keeps flipping those things around. But I'm not going to be changing the sort key very often, hopefully at this point. And so the device has some attributes. What are the device attributes? We have a network provider ID. We have the customer ID. So we already have the customer ID because the device item is partitioned on the customer ID. But I do need a network provider ID. So this will be a provider ID. And so that would be provider one, let's call that. And so that's now we have network providers, and let's add a network provider here for provider one. This describes provider one. And what properties providers have, basically a name and other details. So we can go ahead and add those. And details. Right, and so that's map. And this could be AT, well, it's not used. Let's say it's just provider, some provider. I don't want to get into any kind of representing anybody that shouldn't be. So it's some provider. We have the provider item and some provider details. And one of the access patterns that I might have is get me all the, let me see. There was a question there. Text in browser larger, of course. We can absolutely do that. Hopefully that makes things a little bit better. Let me see what I can also do. I might be able to shrink this window to grow that. Absolutely. There we go. See if shrinking it down this way. Okay. Hopefully that makes things a little better. And okay, so we have, that looks pretty big on my screen. I'm actually, okay, no problem. Okay, so let's say, so where was I? So we've got the access panel says, get me all the devices for customers. So let's add a second device for customer, right? This could be customer's device, another second phone number. And this could be a device. And so maybe this is for a different provider. I'd say they're both provider one, make it easy. And so easy enough to get all the devices for a given customer where, query where PK equals customer ID, starts with D for their device identifier, brings back all the device records, right? Maybe I have a secondary access pattern that says, hey, give me all the devices for a given provider. Okay, well, now I need to add an index, right? Somebody asked, how do we deal with indexes or how do we do indexes? This is, basically the idea here is we're going to go ahead and add new attributes for our index that are going to be on provider ID. GSI1 PK, and let's add GSI1 SK, and this would be on. Let's go ahead and make a mapping function. So with the modeler here, we had two views. We have this view, which is our attribute view. It gives us the values of our attributes. We have this thing I call schema view. Schema view tells us what the types of the various attributes are, except for the entity attribute, because it's always going to be a string. We don't care. We just need to know what entity it is actually in both views. In this case, I'm going to go ahead and create what we call a value template on the GSI1 PK for the device type. And I'm going to reference the provider ID. And so now, see how it copied that value down here to the other device type. And if I go back here, then it actually substitutes the provider ID for that value template, right? You can create complex value templates. I could say, hey, provider ID hash, device type or, whatever, or, device number, and so on and so forth. Now, interestingly enough, I might want to do that here. I might want to actually reference the device's phone number as the sort key for the GSI that I'm about to create. So let's go ahead and create a new attribute here, which would be number. And we're going to say this is, and this one is, and we're going to go ahead and create a couple of mapping functions here. So in here now we've got the value template that's going to say we want D hash number. Right. And for our GSI SK, we're going to want the number. And so this is functionality that's kind of exclusive to the web modeler right now. It's one of the reasons I like using it, because I can go ahead and then as I update these individual attributes, it will reflect the changes. So now what I have is, this GSI1 PK, GSI1 SK, they're substituting the values of the provider ID and the number attribute into those. And I can go ahead and create those same attributes on the, let's add those here, GSI1 PK, GSI1 SK, and this would be provider ID, and this could just be the provider's, hey record. And so now if I add that GSI, GSI 1, and I go look here, we can see now by provider ID, I have a list of my phone numbers. Oh, it looks like I am missing something here. Oh yeah, GSI1SK is new. We want that to be A, right? And then what's happening here? Why am I seeing new? Something broke. Oh, I think I know what happened. I'm just going to go ahead and save this to the file and reload it real quick. I think I have a bad reference in a cell that's being duplicated. I'll fix that bug after the call here. I can go on. So, yeah, okay. That's a function. If nobody needs to know why, but I know why that bug just hit me, and I will not have that happen again, and I will fix that bug right after this call. Anyways, as we get into this GSI now, and I query by the provider ID, I'm going to get a list of the devices by their phone numbers, which could be, hey, give me all the provider, all the mobile devices for this provider in this area code, for example, right? That might be a query where I need to get a hold of, or, and maybe there could be some state or something on these devices. Give me everything that's online in this area code, whatnot. We could create those keys as well. But the idea here is that when I query the table, I'm going to have a set of access patterns. They're basically around the customer. They're customer-centric access patterns. Give me all the customer's devices. Give me all the transactions for a customer for these devices. We're going to go ahead and set up some transaction items here in a second. We'll see how those are laid out. But we have a different set of access patterns that are going to be by provider, and all of those by provider access patterns need to be executed against the index, the GSI. And what we've really done is we've regrouped those items. And you can imagine if I have many customer partitions with many numbers, but they're all on the same provider, essentially what we've done is we've cut across all those customer partitions. And let's go ahead and just create that right now. We can create customer 2. Customer 2 has his own record. This is customer. And he has name details. This could be Jane Doe. And some details to describe that customer. And then this customer has devices. So we're going to go ahead and create a device. Devices, as you see, it created that composite that it maps the value. The value is actually new. So if I update the number here, 512, 555, then it'll automatically update the sort key for this customer, right? And if I went ahead and, as you notice, it updated the sort key for GSI1SK because there's a value template there. And if I change the provider ID here to provider 1, then it also updates that. And if we go back to our partition here, we can see we actually see all 3 of those records, right? The 2 devices for customer 1 and the single device for customer 2, they've been regrouped into a different partition. And this is what indexes are for. Essentially, what we're trying to do is create interesting groupings of items on the table. And if you think about what we've done here, I've created these joins. Right now I have customers, they're joined to that join between customer and smart cell phones. That's a one-to-many. Network providers to smart cell phones is a one-to-many. And we're grouping these smart cell phones or these mobile devices on multiple dimensions, right? Essentially, I'm joining to the customer's table, I'm joining to the network provider's table. And that join is represented both on the primary table here between the customer and the devices, right? I could say, give me everything that's, starts with D and gives me all the devices for the customer. If I want, I could, select everything out of the partition and filter on customers and devices, right? But that might get messy. We'll see in a second when we start adding transactions. It depends on how busy a customer is. But if you think about an individual customer, right, how many transactions do you execute on your mobile devices? We'll talk about that when we get to transactions, but probably not many. So filter conditions are going to work pretty well in these. When we get to that discussion, we'll talk a lot about using filter conditions to knock things out. Essentially, the joins are maintained here in this partition, And on the index, we've essentially regrouped or rejoined those items or those mobile device items on a different dimension, right? So again, the types of queries we can execute here, give me all the devices in a given area code. We could create a value template, which is status and area code, right? So if I added maybe a property to the device type, which is status, and then I create this, edit the value template. Status here could be online. This could be offline. And then this one might be online. And let's go ahead and update our value template here. So we're actually going to go on a composite key, which could be, composite keys where you use multiple attributes together to create a leading key condition that's interesting for your query. And in this case, status is that leading key condition we're going to be looking for. That's going to allow us to create what we call faceted sort, right? So if I look at this now, after modifying that value template, my partition keys are online and offline for the provider. So if I go back over here, I'm going to see I have an online partition for provider 1. I have an offline partition for provider 1. So I can say, give me all the online devices in the 512 area code for provider 1, right? And in this case, maybe what I'm going to do is I'm not really interested in the provider metadata. So let's go ahead and delete these attributes. And, there's also what you can do is project provider metadata that I need, right? The provider metadata is probably pretty small, so I don't really need to join it, so to speak, from the provider item. I don't necessarily even need this provider item, right? We could actually just go ahead and kill this provider item, right? And if I did that, then what I'm going to do is I'm just going to keep the provider metadata, tack it onto every mobile device, for example. That way, if I have, provider, let's call P data. And that could be like some map of information about the provider that's relevant for, this device. When I go look at it, yes, it's duplicated across all devices, but the advantage of doing this is that when I go queries GSI1 and I say, give me online, provider ID starts with area code 512, it comes back and I have all the provider metadata. Right, the provider metadata is not going to change very often, right? As a matter of fact, probably almost never changes. And when it does change, you could catch that update with streams and Lambda and potentially update. Now that there, when you think about that might be one of those updates that makes me pause, right? Because I always talk about this, like when to denormalize the data. And this is actually a really good use case when you think about it, because mobile device numbers, I mean, we're talking about millions and millions, tens of millions, right? So yeah, maybe this projection isn't good if that data is not immutable, right? That data better be immutable, because if it ever does update, you're talking about having to go back and touch tens of millions of items. So this is one of those use cases where you look at that projected data and you want to make sure that what you're sending down there is not something that's going to get updated ever if in the life cycle of this data, right? Because that's something that could be a very expensive update if this is a table for a large that's managing mobile devices for an extremely large provider. Think like an AT&T or a Sprint, right? I mean, these guys don't do a couple 100,000 phones, right? They do a couple 100 million phones. That's a little different. So. Actually a nice discussion on when to denormalize and when not to denormalize, right? Don't fan out data across hundreds of millions of items that's going to need to be updated even, anytime. But if the data is, distributed across, tens of thousands of items, it doesn't update, frequently, don't hesitate to do that kind of stuff. Just make sure that there's an access pattern which allows me to get a hold of the data, without too much pain. When I do need to update that denormalized data. In this case, I would recommend the projected data in this provider map should be stuff that would never change in the life cycle of these items. And then that way, when I query the index, I'm going to get online, offline devices by provider ID and area code or whatever other dimension we want to query on. So that's a good example of creating a part. And I can actually do that in both. Let's say I have an access pattern that says, give me all devices for a provider. Let's forget the scale here, but let's say all devices for a provider. I have another access pattern that says, give me all the online or offline devices for a provider in a given area code. if I have those two access patterns, and maybe what I want to do is I don't want to put this value template here. I'd rather put this faceted, sort, so to speak, or this partition sort on the sort key instead of on the partition key, because this does, and we look at the index, you'll see what this does is actually puts all of those items now into the same partition. So I could say, hey, give me everything for a provider. Select off the GSI by provider ID. It gives me everything for the provider. Give me everything that's offline in area code 512. Okay, where provider ID 1 starts with offline hash 512. Everything online, so to speak, everything online or offline, right? So you get that starts with condition on state and area code, but you also get the full bucket of everything. Right. Again, it all depends on how much data, what's the velocity of data inside of the partition. I would start to look at how frequently do these device items update, because, again, hotkeys, DynamoDB supports 1,000 writes per second. Doesn't really matter how big the partitions are, but, understand that there's going to be, some limitation to the amount of updates you can execute, to the GSI partition. So if we're talking hundreds of millions of devices in a given provider partition, it's not that we can't do it, but those devices should probably not be updating very frequently, because you only get 1,000 writes a second, right? So, again, think of the dimensions here. We could split it out across multiple partitions by faceting on the partition key instead of the sort key, or we could add artificial, shards to that partition key as well. So let's take a look at that. Maybe what we have here is a partition key that is, or a number of updates to these device items are high velocity. Let's assume that. Okay, we're going to be getting a large number of device updates, per second across the provider space, and so we actually need to distribute this data intelligently. And so what we're going to do is we're going to go ahead and create these offline online buckets on the partition key. That'll be our first thing we're going to do to kind of segregate the data, but that might not be enough, right? I mean, my online devices might be, a couple tens of millions, right? And so and with updates coming frequently, that's not going to work with 1,000 WCUs. So what I'm going to try and get an idea of is what's the transaction rate that we need to design for, right? How many updates per second across the provider space are we going to be needing to support? And then what we're going to do is we're going to add some artificial sharding to this design. And that's going to be in the form of a shard key, right? So let's go ahead and add that to our what do you call it? And this is going to be basically some random value, but maybe not random value, right? I might want to say maybe my access pattern is, does this mobile number belong to this provider? Okay, maybe I have a call record coming in or some sort of mobile transaction. I need to identify the provider to annotate, the record. And so, and I don't want to query across many partitions, right? So let's go first. We'll add the random shard key and take a look at this and see what it looks like. This is actually turning out to be a very interesting use case based on scale. I hadn't thought about that before, but it's a discussion of write sharding, which is not something that the common user has to worry about, right? Most of us, we don't need to worry about artificially distributing the work, but guys like cell network providers, yeah, they need to. So in this case, what's happening now is you'll see we have online hash provider 1 or provider ID hash some random number or some artificial range, right? Let's say I want to support 10,000 updates per second. So that range then would be 0 to 9. Theoretically, I would, every time a device gets registered in the system, I'm going to salt the partition key on GSI 1 with a random value between 0 and 9 tacked onto the end of it. And now when I go back and look at my GSI, essentially what happens is every provider has an online partition, has 10 online partitions, partitions 0 to 9, and those numbers are randomly distributed across those 10 partitions. And so if I need to get all the online phones in a given area code for a given provider, I issue 10 parallel queries and I say, okay, get me everything across partitions 0 to 9 that starts with 512. This gives me the ability to, essentially create a distributed process that's going to ingest all of that data, process it in parallel, and execute it as a distributed workload instead of paging across all the items within a single partition. It also gives me the ability to update items at high frequency without killing the GSI. Right, the GSI again, supports 1,000 WCUs, 1,000 updates per second. Assuming these items are small, that's 1,000 updates per second if they're less than 1 kilobyte. If they're larger than 1 kilobyte, then each kilobyte is WCU. So it's a factor of size of the item and rate of update that we're going to determine what that the shard factor, so to speak, would be. But that's the nature of this type of workload. Now, let's say that it's not really just a workload that says get me all of the items. As I said, it's get me all the numbers that are online for a given provider. That's great. Well, how about does this number belong to this provider? I don't know why we might have that pattern, but let's say we do. In that particular case, I don't necessarily want to issue 10 queries in parallel. I'd rather issue one, query in parallel. So, what we would actually do here is alter the shard key. And instead of just doing a random 0 to n, I would actually say, well, I'll tell you what, give me the hash code of the phone number. And in Java, there's a function where you can just say hash code of any, object, and it'll return a MD5 hash. And then I can actually say, okay, so hash code of number and modulo by 10. Okay, and it's not, that gives me a number essentially to add on to the end of that is my shard key. And so I know for this phone number, it belongs in shard n. And so when you go to say, hey, what is the shard key for a given, I think this will work. If I go look at the value here, yep, it'll work. So if I go back to the index, that's on, I don't want to do that on the partition key. Yes, I do. So what ends up happening here is that for each one of these phone numbers, if I hash code this phone number modulo by 10, it's going to come out to 7. If I hash code this phone number modulo by 10, it'll come out to 7. Right, so on. So these two numbers will exist in the same partition. And if I need to go find this number, I could say, hey, give me the hash code of this phone number. Oh, it's in partition 7. Let me query online hash p1 hash 7 and see if this phone number exists in there. If it doesn't exist in that partition, then it doesn't exist. It doesn't belong to this provider. See what I'm saying? So it's just I just thought about that as an interesting way to be able to selectively write shard. That is something, selective write sharding is a technique we use when we need to be able to retrieve a single item from a sharded collection of items. And we need to do this efficiently. And there's a lot of really good use cases for this when you're operating at scale and you're doing, large scale aggregations on your DynamoDB tables. All right, so that's enough of that between providers and customers and whatnot. I'm going to go take a look and see if we've had any interesting questions here that I should probably look at. Hey, yeah, actually, I like this question because coming from an MS background, this is basically the same as Cosmos DB. You know what? These techniques, they apply to every single, NoSQL database out there. They're all the same. There is no difference, right? As a MongoDB has a collection, collections have documents, documents have attributes. They're all indexed on underbar ID. We're going to go ahead and use underbar ID as our primary indexing structure. I can put a composite key value into the underbar ID value and query on starts with, right? The same things I'm doing here, I can create the exact same data structures because that's what NoSQL databases do. They replace joins with indexes. We're going to create lots of objects that are related to each other. We're going to load them into these databases. We're going to decorate them with attributes that we're going to populate with common values, and then we're going to create indexes to go get them. So to say, yes, it's basically the same as Cosmos DB. Absolutely. It's basically the same as Cosmos. It's basically the same as MongoDB too. Same as Couchbase, same as, Cassandra, same as any other NoSQL database. These things are indexed object stores, right? They're not, proprietary database stacks with different modeling tech patterns for each individual one. They all model data the same way. Once you get your head around it, it's just like a relational database. It's just like saying, MS SQL is like Oracle, right? Yeah, they kind of are. So when you look at NoSQL databases, and once you kind of get to that mindset where you kind of understand, hey, here's how I would just create those indexed object collections in any one of these types of platforms, then you really start to get this stuff, right? It's not a difficult thing once you kind of get your head around it. Let me see. All right, I'm just going to go ahead and keep going here. Okay, so let's go ahead and keep it and just keep going on. Add some. What do we got now? So we've kind of thoroughly discussed the relationship between customers and mobile devices, between network providers and mobile devices. We've queried on multiple dimensions, and okay, let's say now here we've got mobile devices have an explicit relationship to what they call accounts. I was referring to these as the payment methods, which he has on this table down here. But I was again a little confused here because for me a mobile device that is an account. Or you might have customers that have an account that has multiple accounts that have multiple mobile devices, but I don't see how this relationship works this way, right? I think that it's actually to treat these account objects more as payment instruments. Like I said, Visa, whatnot, PayPal works better because I'm going to be registering those different payment instruments on my mobile devices, right? I might have multiple mobile devices, but only one or two of them have these payment instruments registered, so to speak. So let's go ahead and model that. In this particular case, now what we've got is a new type of item. It's going to go into this partition. This item is going to be we'll call it a instrument, payment. What do we want to call it? We'll call it an instrument. And let's call it an account. There we go, because that's what's in the model. Hey, so what do accounts have? Accounts have, some mobile device number that they're actually, what is it? We had a number, right? Yeah, mobile device number that they are looking at being associated with. So this will be, let's say 323.3333. And what else did they have? They have account type, name, and other details. Okay, so let's say, and those would be interesting dimensions to index as well. So we'll have an account type, a type. We will have a details. And what else was there? We don't need to worry about that. I guess we could have the name. Okay, so there we go. So the account type could be, let's call it credit card. The details is just going to be some map, like, whatever. And the name would be, I don't know, primary. Okay, and so this key is going to be the composite that we want. It's going to be the same composite as this key, right? So let's go ahead and just copy that value template from here, post it in here. And now when I go back here, you can see that this device has an account associated with it, right? So if I want to get all the accounts for a given device for a given customer, now again, let's start thinking about volume here. Customers, okay, yeah, maybe we have a corporate customer that might be the exception here with thousands and thousands of devices that they potentially have, in which case I would say, well, again, partition those devices across multiple customer partitions. But most customers, the vast majority of customers are going to have, one or two devices, maybe a handful of devices. They're going to execute, a handful of transactions a day. They're not going to be executing things at high volume. So, when I say, okay, let's go ahead and use filter conditions, I can say, great, let me go ahead and, get me for this customer ID and this sort key filter on account. Right, I don't need to get the device information, but I could say, hey, when I query for the accounts for a given device, I need to see the account metadata. So no problem. Let me say query where customer ID equals C1. And actually, I need to change this a little bit because these sort keys are not, I just noticed that these sort keys are duplicating. And so we actually have to have a unique ID tacked onto the end of both of those in order to be able to, so this is a device, this is the D hash. And what we're going to do here is we're going to say, we can add to the account. This will be an ID, account ID, and to the device. We don't need to really add anything because the device ID is the phone number. And when I go back and create this key for the account, I will add onto the end of it. And for those who are familiar with DynamoDB, you know what I'm doing. But for those who aren't, what I'm doing is creating a unique sort key on the table for the account item and the device item. And I need to do this because otherwise, when I create the account, I will overwrite the device. And in this particular structure now, here's what I can do. I can say, that's right. Is that right? Yep. And so the account ID is going to be A1. And so now what we can see here is a device 512.323.3333 has multiple devices, has multiple accounts, one or more accounts underneath it that are going to be uniquely identified by the actual account ID. So this device item, again, doesn't need a unique, anything to be appended to it because the phone number itself defines the uniqueness of the device record. But for every other, account that we add to the device, I'm going to need to create a unique sort key. Otherwise, on the table, it will collide. Now, in the GSI, it doesn't matter, right? I could say, okay, on the GSI, let me go ahead and just use the phone number if this was on the GSI, but because we maintain uniqueness of the items as we transfer them to the GSI for you. But on the table, it's up to you, and that's why we're going to add that sort key. So that takes care of this relationship, which would be accounts to mobile devices, right? So we've got that kind of hierarchy here. Customer has multiple mobile devices, and a mobile device might have multiple accounts. And the next thing that's going to happen is that devices are going to end up with transactions. And so that might be, one of the access patterns here where I say, get me all the transactions for a given device. Now, this is why in the beginning I said we need to lead these records with the D, because transactions, what I'm going to do with these guys is I'm going to partition them on the actual number, but I don't want them to pollute, all of, and we might decide to go ahead and do that. As a matter of fact, based on my advice earlier, which is most customers don't really have that many transactions, they don't have that many devices, let's go ahead and do that. I'm going to remove these prefixes from our value templates because I'm going to let everything just show up as faceted by phone number, and the items that we don't want, we're just going to go ahead and filter out. Did I do that right? Yes. And so now everything's just phone number, phone number, phone number. And let's say if I want all the devices for a given customer, well, everything's kind of intermixed, right? Everything's, what I can say is select by customer ID, filter on type equals device. Okay, or type equals customer. Okay, that gives me all the devices and the customer metadata. And sure, I'm going to read a bunch of stuff that maybe I don't really care about. But like I said, how many transactions does a given customer have? Let's say that the life cycle of this table is going to be a 30-day or 60-day rolling table, right? At the end of the month, I'm going to roll the table over and I'm going to say, okay, let's start a new table. How many transactions does a given customer have during a month? How large are these items? Probably not all that big. How often does this read query happen? Probably not very frequently, right? So, again, filter conditions are fine. The reads will be a little bit pricier than if I had a faceted sort or a selective index, but executing filters inside of the customer partition to get very specific items or types of items, that's actually fully acceptable when you're dealing with limited data sets, right? We're not talking about gigabytes of data here. We're probably not even talking about megabytes of data. We're talking about tens of kilobytes of data, and filtering through that is not going to cost you a lot of money. But again, let's not make assumptions, right? Let's actually, when we go into modeling the data, we actually go into setting up your tables. What we're going to try and do is, what are the actual sizes of these items? What's the real cost of these queries? And if I load this table with representative data, one of the best thing about it is with DynamoDB is you get this thing called return consume capacity. It's one of the parameters you can set on your SDK. So you can just set that to true, and you can actually see what the query costs, right? Here's some sample data that I brought from my production system and poured it into my new model. Let's run these queries. Let's see that return consume capacity. Let's look at the number of queries we have to support per second. And there's going to be a breakpoint. Rob and I are going to be doing a session next month on cost optimization, and Rob did some really good work on how how to find these breakpoints, right? When to create the index, when to use the table scan, right? These are the types of things that you do to determine, hey, what's more cost efficient here, to build the selective read structure or to pay the cost of the complex write, so to speak, right? So in this case, what we're going to do is assume that the cost of the read of a non-selective read using filter conditions is going to be just fine for our use case. So the next thing we need to add here is transactions for the given devices. Let's go ahead and add those. Let's say this is going to be what did our model call it over here? Yes, transactions. Okay, transactions have and a transaction has, what does it have? As a mobile payment method code, we're going to call that the account ID. It has the retail outlet ID. It has smartphone number, transaction code. Okay, so let's say, what do we need here? It's going to have a code. It's going to have account ID. It's going to have a retailer ID. And I would imagine it's going to have other details with the things like, size of transaction and whatnot. And it's also going to have a date. So let's go ahead and say timestamp. We can stick a date string in there. This will be retailer 1. This will be account 1. Transaction code, whatever, purchase. And so what do we want this to be? This is going to be the phone number. So this is going to be a number. And let's go ahead and say it's this number. Oops. And then it's going to have a transaction ID for uniqueness. Okay, so this will be T1. And then this key here is going to be the number. It's going to be the number. Timestamp. Where'd it go? Timestamp and transaction ID. Because in case we get 2 transactions at the exact same time, we still need to be guaranteed unique. They should have a unique transaction ID. Right. Yes. And so now, what you can see here is that there's a date range list of transactions underneath this underneath this cell number. So I could say, hey, okay, for this given cell number, give me the transactions between date 1 and date 2. I could say, give me everything that's between cell number hash date 1 and cell number hash date 2. That brings back all of the transactions for a given cell number. That does it very selectively. I could choose to just use filter conditions on the timestamp instead, and then I can add additional filter conditions to bring back the other objects that are interesting to me. So I could say, hey, bring back, all of the data that describes the transactions and the device, and the accounts that are potentially available for this device, so that I can have all the account metadata and everything in one request, right? I mean, I can add the filter conditions to do that easily enough. I can have a date range condition on timestamp as a filter condition instead of a sort key condition. I can say, great, give me everything that has a number. I could add all of this as filter conditions, where a number equals X, where a timestamp is between date 1 and date 2. I could say, or account equals, or type equals account, right? It bring back all the transactions for a given phone number between the date range and all the account objects. At the client side, I can say, okay, which are the accounts for these transactions, and match those up and get that metadata, right? There's a variety of ways to be able to slice and dice through this data. What's interesting, again, when you think about the corner case of most customers, 99.999% of the users, they're not going to have thousands of transactions in their partitions every week, every month, or whatever the life cycle is of the data on this table. So using filter conditions can be really, really nice way to slice through the data without creating a bunch of indexes, right? If you create a bunch of indexes and a bunch of selective queries to support a bunch of selective queries, that if I have a high velocity read pattern with large data sets, that works really well. But if I'm doing it in this use case, essentially what I'm doing is I'm duplicating, maybe tripling or quadrupling my write cost, because every time I write an object into the table, it's also propagating across to the GSIs. And what is the read cost? Is the read cost much lower? And this is where we talk about breakpoints, right? We get a cost optimization, and when to design for the read, when to optimize for the read, when to optimize for the write. It's all about cost, modeling. And this is a function that's kind of, I think, is long lost, or not necessarily. I mean, it actually is long lost, because I started writing code. I hate to say it, but I started writing the code back in the day when we had to pack structs, because if you needed to get some data in the system, you need to find some bit on some byte that somebody else wasn't using, so you could use it for your bit flag, right? And literally that's how it worked, because that memory was at such a premium, right? And the cost of storage was so high that you wanted to account for every bit, every byte, and modeling for cost was a big deal. These days, it's all free, right? It's just a bunch of stuff, right? And developers get lazy, and that's what causes your AWS bills to go through the roof. And that's why there's cloud consultancies out there to teach you how to spend less, right? So again, don't be afraid of modeling things in a way that doesn't look like, oh, it's hard to read that. Oh, I wouldn't want to do that. Because sometimes hard to read is actually cost less than making it easy to read, because it's harder to write or more expensive to write. Anyways, all right. So we're running up to the end of the hour here. Let's go ahead and open it up here. Does anybody have any questions that they want me to address? I know we've got some good moderators on today, so I imagine most of those questions are, let's talk about some of this stuff. Okay, yeah, rolling the data at the end of the month, right? You would just transfer static data like device, account, customer, exclude transactions. Yeah, potentially you could have like a raw data table. Again, this is a completely theoretical exercise. To tell you the truth, that's actually a really good question, right? Do I really want that data to persist on the same table? This could be a really good reason why I'd want to use multiple tables. Maybe selecting the metadata that describes the devices and the customer and the accounts that the customer has. That could be data, as you said, which persists month to month. But the transaction data I'm only really interested in on a monthly basis. Maybe what I'll do is I'll just TTL, right? The transaction data, right? DynamoDB has TTL. You have a whole lifecycle management process on that TTL data. We've got change data capture with streams and Lambda. So, maybe I just, the data is it's not really a rolling the table over. It's just that the items that, are the static data that lives through the entire service life cycle. That's your customer metadata, your account metadata, whatnot. They just have a different life cycle than the transaction data. That's okay. We'll just TTL that transaction data. And, maybe what I'm doing there is I'm taking that transaction data and I'm bundling it up into, sending it to Kinesis Firehose and shooting it into an S3 bucket so we can query the historical data with Athena, right? Again, this is one of the nice things about DynamoDB. It's an ecosystem of tooling that just can't be beat. When you start, getting your hands into this thing, you start to realize, it's not that my data doesn't have to just live in the database. The database can be just where it lives while I need it as an online data store. And then, it's kind of like, tiered storage built in through all the tooling we have. You can migrate that data from your DynamoDB table gracefully into a long-term cold storage environment where it can still be queried when you need it, right? And so that's we have so many customers doing that now, right? There's just, they only need access to data for a small period of time. So, good question here. When you roll the table, let's not roll the table because, like you said, there's a lot of static data in there. Either we're going to leave this data, if we're doing table drops and table rolls, then the static data should live somewhere else. My access patterns may not necessarily be actually querying that data together. If the data is being queried together and I need this data, to live in an optimized read, structure, let's use TTL and move that data, off the table when it's no longer necessary, right? So a lot of options for you, lots of different things people can do. Let me see. Thank you. Yes, this is the big value, right? This is formula supports entities, things like that, working to get that stuff pushed back up into Workbench. Look for that to happen. These tools are compatible with each other from model, the model layer, right? Workbench and the web modeler. Anything you do in Workbench, you can export, send into the web modeler and vice versa. The Workbench right now just ignores the extra metadata that the modeler creates. It doesn't destroy it, doesn't step on it in any way, but it doesn't care about it. Whereas when you load the models into the Workbench, it's going to go ahead and use all that entity modeling information and whatnot. All right. So I think it looks like the moderator's done a good job. What do you know? You put knowledgeable people on the line to answer all the questions. Hopefully you guys got something out of today's session. I thought it was a really good discussion. We hit on some subjects I really don't dive deep in very long or very often. The right sharding, selective right sharding, right? What to do with data at scale, how to use complex filter conditions to satisfy, queries across multiple types of range conditions, right? Which, would normally, if I issue those range conditions on the sort key, I kind of exclude all those other items. But if I issue range conditions as a filter condition, I can execute or conditions on filters, which allow me to more flexibly retrieve data, bits and pieces of data across the partition. And this is a really good technique to use when your partitions are relatively small, right? If I'm not carving through a lot of data with those filter conditions, they can be very, very efficient, even if they're only returning a fraction of the data that you're filtering through. So don't shy away from those filter conditions. We use them all the time. All right. So all right. Well, so a couple other questions here that I'd like to get more into roadmap functions and features, but I can't really talk too much of that stuff in a public forum. So if you have specific questions about when tools will do what features might be supported, whatnot, reach out to your account team. We can have those discussions, but I can't really talk to things that might or might not be happening in the roadmap. Other than that, we're at the top of the hour. I really appreciate you guys taking the time out of your day to watch this stuff. I love doing it. As you can tell, the conversations are really good for me. So as long as you guys are getting value out of this stuff, I'll be happy to keep doing it. And thanks, Rob and Lee, for today's moderators. And we'll see you in a couple of weeks. All right. Talk to you guys later.